Good day. In this video we're going to talk about nanotechnology. Nanotechnology is the terminology used in science and engineering to describe phenomena that occur at nanoscale scales and are used in the design, characterization, manufacture, and application of materials, structures, devices, and systems. Applications of nanotechnology. Nanotechnology is helping to considerably improve, even revolutionize, many technologies and industry sectors, such as information technology. Nanotechnology has greatly contributed to major advances in computing and electronics, leading to faster, smaller, and more portable systems that can manage and store larger and larger amounts of information. Homeland security. Nanomaterials could be used to create highly sensitive sensors capable of detecting hazardous materials in the air. For example, carbon-based nanotubes are relatively inexpensive and consume minimal power. Medicine. Other potential applications of nanotechnology in medicine include nanoadjuvants with immunomodulatory properties used to deliver vaccine antigens, the nanoknife, an almost non-invasive method of destroying cancer cells with high-voltage electricity, and carbon nanotubes, which are already a popular way of repairing. Transportation. The main advantages of applying nanotechnology in automobiles include providing lighter and stronger body parts to enhance safety and fuel efficiency, and therefore achieving a better performance over a longer period. Energy. Nanotechnology is being used to reduce the cost of catalysts used in fuel cells. These catalysts produce hydrogen ions from fuel such as methanol. Nanotechnology is also being used to improve the efficiency of membranes used in fuel cells, to separate hydrogen ions from other gases, such as oxygen. Food safety. Nanoparticles are manufactured to encapsulate food ingredients and additives to mask their unpleasant tastes and flavors, protect the encapsulated ingredients from degradation, as well as to improve the dispersion of water-insoluble food ingredients. And environmental science. Nanotechnology has enormous potential for providing innovative solutions to a wide range of environmental issues. These include improved methods for reducing pollution, water treatment, environmental sensing, remediation, and making alternative energy sources more cost-effective. The most immediate challenge in nanotechnology is that we need to learn more about materials and their properties at the nanoscale. Universities and corporations across the world are rigorously studying how atoms fit together to form larger structure. Next, because elements at the nanoscale behave differently than they do in their bulk form, there's a concern that some nanoparticles could be toxic. Some doctors worry that the nanoparticles are so small that they could easily cross the blood-brain barrier, a membrane that protects the brain from harmful chemicals in the bloodstream. If we plan on using nanoparticles to coat everything from our clothing to our highways, we need to be sure that they won't poison us. There are some hefty social concerns about nanotechnology too. Nanotechnology may also allow us to create more powerful weapons, both lethal and non-lethal. Some organizations are concerned that we'll only get around to examining the ethical implications of nanotechnology and weaponry after these devices are built. They urge scientists and politicians to examine carefully all the possibilities of nanotechnology before designing increasingly powerful weapons. Next is to identify the dilemmas brought about by nanotechnology. The ethical issues involve the identification and assessment of hazards and risks, non-maleficence, doing no harm, autonomy, or self-determination, justice, or fairness in the distribution of risks, privacy, or in the handling of medical information, and respect for persons. 1. Nanoparticles may damage the lungs. We know that ultra-fine particles from diesel machines, power plants, and incinerators can cause considerable damage to human lungs. 2. Nanoparticles can get into the body through the skin, lungs, and digestive system. This may help create free radicals which can cause cell damage and damage to the DNA. 3. The human body has developed a tolerance to most naturally occurring elements and molecules that it has contact with. It has no natural immunity to new substances and is more likely to find them toxic. And, now, these are the policies formulated. The Australian Industrial Chemicals Introduction Scheme, the Department of Energy issued Order DO 0456.1A on July 15, 2016,